Hello ladies and gentlemen, thanks for tuning in today. This is the sixth lecture of week 6 for GGS300 Quantitative Methods for Geographical Analysis. I hope you're all doing well. I know there's been a lot of work set recently, so this week's actually quite a short week in terms of the amount of lecture material that we're going to cover, and also the fact there's no lab this week as we're going to be doing the midterm exam. Okay, so let's go into detail a bit more on what those updates are. So the fourth assignment is going to be due this Friday on the 4th of October. The discussion boards and the tests, which I hope you've now all completed, are due today on the 1st of October. And as I've already mentioned, there won't be an assignment set this week, so watch out for the midterm exam that will be set. It's absolutely paramount that you do complete the tests in advance, because they're going to really prepare you for the midterm exam. So I really need to make sure that you've had a look at that content, at least attempted it, because it's going to emphasize where you've got gaps in your knowledge that you may need to revise prior to the exam. Okay, so reach out to me if you've got any questions or queries. I have been enjoying engaging with those of you that have been responding to the emails that I've been sending. I know some of you have kind of disappeared off into the ether, so don't be afraid of reaching out to me if you've lost track of where we are on the course. I'd be really keen to hear from you again. And for those of you that have been engaging with me, I've enjoyed speaking to you over emails, and I look forward to working with you through the course, so please keep up that contact. Okay, so today we're going to be focusing on an introduction to data sampling, and in reality I've already touched on sampling quite a bit within the previous lectures. So we've touched on why you would go through a sampling exercise. I'm going to pick up some of that today. I've spoken a little bit about what you can do with the results once you've actually sampled an area, and how you can turn that from frequency distributions into the probability of a future outcome occurring. So we did that in the last couple of lectures. So what is sampling and why do we do it? So far, we've focused on descriptive statistics within the module. So we've focused on the mode, the mean, the median. We've also focused on the range, the interquartile range, and the coefficient of variation, and the standard deviation, and some other metrics as well. But generally, we focus on these descriptive techniques, which allow us to represent distributions in either single numbers or ranges of numbers, absolute or relative. And they're really handy, and they are somewhat simpler than many of the other techniques that we're going to get into later in the course, but they provide a really important basic understanding, because as I mentioned before, the knowledge from the first part of the course sets the key foundation for understanding those other more complex methods, such as the inferential statistics techniques that we're going to be covering from the next few weeks onwards. So inferential statistics, what are they? Well, essentially, it's where we make generalizations about a statistical population based on information which we obtain from perhaps just a sample of that population. And just to recap, in terms of definitions, the population is essentially the total number of entities within a boundary which we set for a particular study. So if I tell you that we're going to sample all of the people or the premises within the city of Fairfax, then the population for that study area is going to be all of the people or the premises in the city of Fairfax. And then in terms of a sample, that's a subset of the population selected for detailed analysis. So let's say that we pick 100 households or 100 businesses within Fairfax City. That would become the proportion that we end up sampling from the overall population. Hence, that's the sample. Okay, so what are the aims of sampling? Well, essentially, we want to attempt to make an inference about a whole population. So we want to try to get information from a small but representative number of entities within the total number of the population. And then we want to generalize those findings to everybody or everything that's in that total population without needing to apply that method to every single entity. Okay, so it's absolutely important, as you see here on the second point, that this is a representative sample. Okay, so if you don't manage to capture a sample which fully represents your population, then you're highly likely to introduce bias into your results, and this, could give you the wrong outcomes. You can make the wrong decisions. This could be, this could be a really serious error if you were making decisions which have a profound impact on people's lives, or if you're investing, millions or billions of dollars in new projects. You need to make sure that you get this right. Okay, and quality matters. So the quality of the samples that we pick determines the quality of the statistical analysis. So how rigorous is the method that you develop in order to capture that information from the sample? How robust are those findings overall in terms of their relevance to the whole population? So why is sampling needed? And I spoke before that this was, kind of driven by time considerations. Obviously, time is money, so the cost effectiveness of sampling is an important thing. Of course, some populations can be very large, or you can't easily access them, so that's another issue. And you can, if designed in a statistically robust way, actually gain quite highly accurate results from sampling populations. And you're able to repeat this often. So it's a kind of quick and cheap way to get insights on a regular basis. One example are the monthly or the quarterly updates on the number of jobs. So labour market information. So this is highly geographic. Economic geographers will be really interested in who's employed in different sectors and how many businesses there are in different locations. So it's highly spatially granular data. The problem is that the more spatially granular you get, and the more sampling you're going to need to do. Of course, you can't go out and you can't survey monthly or quarterly every single business, to understand how many people they've recruited, how many job vacancies they have, this type of thing. So as a consequence, you need to develop a survey method, and a lot of those statistics that are released by economic statistical bureaus, they're then used to inform government policies or business decisions. Are developed via sampling methods. Okay, so CEOs of companies are pretty good at responding to surveys when they are sent out. I've done a couple of these before, and you do get responses. So yeah, it's a relatively quick and efficient way to get repeated information. And it can provide quite in-depth detail, but then I think it's important for me to state that there's a big trade-off between the level of sampling which you do, so the number of entities that you sample, so the width of the sample space that you explore, versus the depth. So how much time do you spend trying to get that information from one individual place or person? So a good example of this is if you're interested in attitudes towards the environment, for example, you could just scrape as much information as you could possibly get from Twitter and try and interpret it, and that will give you a very wide sample because you've got millions or billions of tweets to try and pull from. But you wouldn't get that much depth from each one of those, and you wouldn't be able to easily engage with each person because that would require a detailed discussion. Then the kind of flip side of that is, well, what actually if I interview 100 people for a PhD thesis, and I'm going to do 2-hour interviews with each person, then that's a very large amount of detail. It's a lot of depth that you're able to get from those small numbers of people, but it's very rich contextual information. So you have this trade-off in how many people do you sample and how much time do you dedicate to each individual person. And these are the types of issues which you need to make decisions on when you're designing studies to undertake. Okay, so the goal of sampling is to derive a truly representative set of results which hopefully mitigate bias, or you're never going to eliminate all bias in the sample, but you want it to be within an acceptable range. So hopefully you're able to minimize the level of bias within your sample. And the sample design is basically a procedure used to select the individuals from the population, and we're going to go over this within this lecture. So to get a high sampling accuracy, we need to have a properly designed sampling framework. And then we need to have an appropriate number of samples to represent the total number of entities within the population. So there's a relationship between accuracy, cost, and sample size, and I'm going to try to articulate this here. So essentially, sampling does concern me. I'm doing a project which I've mentioned to you before at the moment on sampling Wi-Fi hotspots, and this is quite well researched. It's called war driving, essentially because there was a film where, you know, back in the 80s or 90s, you would dial up numbers in order to see whether they had internet access. I think that's what it was, and then they were able to work out how many people were able to connect. It is from a film anyway, but the point is that war driving now essentially is where you drive along with a radio antenna, you try and passively detect all of the Wi-Fi access points. And in this paper, I'm arguing that a lot of the papers that have been written on this subject over the past 15 or 20 years do not fully reflect the necessary statistical kind of gold standard techniques that you should put in place if you're going to design a sampling study. So it's actually highly relevant for what we're doing here, and within that I've taken my own sample and I try and compare it to a predictive model to show how this method doesn't properly sample areas, essentially under samples, and there's systemic bias in the method, and that's what I'm trying to argue. So as a consequence, I am concerned about the degree to which, you know, I've sampled enough in order to draw these conclusions, because you want your scientific papers to be rigorous and robust, and to be resting on a weight of good evidence, and therefore you need to ensure that you've collected enough data, and so this is why I am concerned about this in the stuff that I do when I'm not teaching GGS300. Okay, so what do we have here? Well, essentially this is just a theoretical description of the trade-off which you face between small and large sample sizes. So down here we have small sample sizes, and here we have large sample sizes. On the A-axis here we have the level of imprecision in the sampling, and it goes from low to high. And then on the B side here on the Y-axis we have the amount of effort, so cost and time required to sample. It goes from low to high. So if I took a small sample here, it would have a high level of imprecision, but it would be very quick and easy. It would be like very efficient for me to take that small sample. But as we increase the sample size, essentially the level of imprecision in the data decreases, but we do get an increase in the amount of cost and time that it takes in order to conduct that survey. So this is something that you need to be aware of. And in the previous lecture, we focused on probability, and there was an example where we were tossing a coin and seeing whether, looking at the relative frequency and potentially the probability of different outcomes, so whether it's a heads or a tails. And I've just pulled this table from the previous lecture slides because we have the number of trials here, n, so we have 10 trials, 100, 1,000, etc. to 20,000. We have the number of heads that are recorded, so the frequency of heads, 8, 62, 473. And then we have the relative frequency there, so this is the number of heads divided by the number of tosses, the number of trials. And we get basically a frequency, but it can also be interpreted as a probability. And what's important is that when we're down here on the small number of trials, 10 or 100, we're over here on the left-hand side of this graph. So it's a small sample. There's potentially a high degree of imprecision, but it's very easy to take the sample. So if you look over here, when we only flip the coin 10 times, we get 8 heads, and that would indicate that the relative frequency would be about 0.8. And therefore, that if you were to flip the coin again, you've got a 0.8 chance, a 0.8 chance, so an 80% chance of it being a heads. And we just know that that's not true, because you'd have approximately a 50% chance of flipping a heads or a tail, based on the fact that you've got 2 outcomes and the probability of each outcome is evenly weighted. So that's a good example of how you have imprecision in your resulting data. And that level of imprecision, actually, as we start to increase the number of trials, gets a lot smaller. So we drop from 0.8 to 0.62. And then by the time we go up to 1,000 trials, we're getting very, very close to the 50% margin, the 0.5 relative frequency or 0.5 probability, depending on which way you want to interpret it. So this is just a general example of how we need to consider these different dimensions when we are thinking about designing a study and we're thinking about going out and collecting data from that target sample to represent the population of interest. So sampling design, there are lots of different types of sampling design. So how do we do that? Sorry, just before we begin, let me just emphasize, there's this random, systematic, stratified, cluster, or hybrid sampling designs, and I'm going to cover that within this lecture now. So the steps in the sampling procedure, there are up to 6 that I state here. So firstly, we need to define a target population. So that's all the individuals which we wish to study. So if I go back to the example which I gave before, if we're going to sample households or businesses in the city of Fairfax, then that is our target population. We can effectively draw a boundary for the city of Fairfax which captures all of those entities in one place. And then that will be a key part of how we then design the sample based on the number of entities within that area. So then we need to define a sample population within a certain sampling frame. So I can't remember whether we covered sampling frame or not in the definition, but it's definitely in the McGrew and the Simon Dadson book. So that's essentially, the sampling frame is the structure that contains the set of elements to be sampled. So let's consider again, that's the boundary line in Fairfax. And then everything within that is what we're wishing to sample. Okay, so then what do we do? Well, we need to select a proper sampling design, and I'll go into this in this lecture, but we could either choose a targeted approach, which isn't based on probability, or we could choose a probability-based sampling design. So I'm a fan of the second one, but I've done quite a bit of the first one, non-probability sampling. And that has its own justifications, but generally within the wider scientific approach, the empirical method, we're probably going to be using more frequently probability-based sampling methods, and we'll cover that today. Okay, then once we've got the sampling design defined, we're going to need to prepare the research instrument and the operational plan for getting the data. So what does that mean? Well, that could be a survey, that could be an interview structure, that could be a device which then you're going to use in order to obtain some quantitative information, a measurement device, for example. But essentially you need to set this up, and you need to make sure that the devices you're using are calibrated. Your survey, if you're using it, or your interviews aren't using leading questions, you need to have tested these. You need to make sure that before you hit your sample, you need to have tested all of the instruments which you're going to provide. So you need to get people to try the survey in advance and review their answers. You need to practice the interviews with various people to know if you're asking the right questions. Okay, and then once you've done the pre-test, as I just mentioned, and then you've revised the sampling plan, you can go out and you can collect the samples. So non-probability sampling designs. So often this is used within the qualitative context. So maybe you're doing case study interviews. And generally, there's two types of non-probability sampling design. So that could be convenience sampling. So that's speaking to people on the street, for example. In the work that I've been doing in the past, it's been based on opportunity sampling. So I'm going to have, a set of smartphone devices in my pocket, and I'm going to download a set of apps on them, and I'm just going to carry them with me everywhere that I go. And I'm going to sense all of the Wi-Fi devices or smartphone devices or satellites or cell towers that I'm able to detect, and I'm just able to do it on no particularly structured basis, essentially. So it's just a convenience sample. And then the second type is a targeted sample. So I did quite a bit of this in my PhD work, and this is where you might say that you hypothesize that this is how the world works, and therefore, in order to understand if that effect exists, you might then decide that you need to speak to a particular person or a group of entities or a market or a particular company within a market of certain industrial sectors. You need to speak to those entities directly. And this is where you can, on theoretical grounds, decide you're not going to probabilistically sample companies, you're going to specifically go to ones that meet your exact criteria. So this could be expert sampling, so you have a panel of experts or subject matter experts. So let me just add in. So it could be expert sampling where you speak to subject matter experts. It could be heterogeneity sampling, so you're looking for a range of ideas or people within your sample. Or it could be a snowballing sample, so you gain some participants and then you use them to find more participants. So you gather momentum in collecting sample data through those existing people who are engaged with you. So the work that I did in my PhD thesis was looking at the impact of digital infrastructure on the economic development of local areas, and I would, as part of the work, there was a lot of quantitative work, but I did some qualitative bits, and I hypothesized that the level of broadband access had a much larger impact on small firms because they don't have huge amounts of resources, and particularly small firms who are in the digital economy because all of their products and services were being mediated across the internet, so they need to have good broadband access. So as a consequence, I chose a targeted sample of basically digital economy startups, and I went out and I worked with the companies to understand how their company processes were designed, how much they were reliant on digital infrastructure, and I was able to get their inputs as to how much having good digital connectivity influenced their growth, their sales, their operational business model, things like this. And that's, in economic geography, that's a fairly standard way that you might go out and try and find information about a group of entities. Okay, so that's non-probability sampling. In terms of probability sampling, there are many, many, many different types of sampling options. So we could have a simple random sample just here. So you just randomly select points across space. So in R, you could say you could call up a random. You could just generate random numbers between 0 and 10. And you could generate for your x-axis and generate the same on your y-axis, and then you could go out and sample all of those points within that area, and that would give you a basic way to try and galvanize the data that you want from an area. It kind of overlooks some of the key aspects of those factors which might influence certain processes. So, for example, you might be better off picking something like a systematic sample or a stratified proportional sample or a stratified disproportional sample if you think that there are other factors which affect the chosen outcome, which maybe a random sample might just overlook. And therefore you need to be cognizant of what the research question is, how you think the world works, and therefore how you should design the study. And then I've just put down here as well that you could use a hybrid style approach where you randomly sample within cluster tiles that you've already identified. So it's a two-stage cluster sample. So you could pick the tiles first, and then you could sample within those tiles. Okay, and then over here on the right-hand side, we've got other types of stratified sampling, and we're going to cover some of these. So, simple random sampling. Every element in the population has an equal chance of being sampled. So I mentioned before that this is where you have a uniform chance of picking any element within the population when you're sampling it. It's fast, it's cheap, it's simple, but you may overlook certain factors which affect the process which you're trying to measure. And that could lead to bias. Okay, so you're introducing bias into your sample by ignoring other factors that might influence the process. Systematic sampling, so this is where you regularly sample individuals of a population, for example. And the locations that you might want to sample could be determined with regular intervals. I do this quite often, and it's very useful. If you create a 1 kilometer grid, for example, and then you take the centroid, so the middle point of that, then you're able to get a value for what's generally happening in each one of those 1 kilometer grids. And that's a very high level of spatial disaggregation. If you're working globally, then 1 kilometer squared is incredibly detailed, but it really just depends on the process which you're studying. There are cons to it. If you're just focusing on Fairfax City, then maybe 1 kilometer squared is too aggregate, and therefore you need to zone in more on those local areas. Maybe you need to change the grid structure, or maybe you need to go into a more spatially granular approach. Especially as, if you were sampling people or individuals or houses, they're more likely to be clustered in space. So if you looked at Fairfax, then you would have a lot of agglomeration of those buildings and people in certain squares, and then in other squares you might not have anything. You might have a couple of houses. So you might want to reconsider using this type of approach if it's a very small local area. So stratified sampling, I'm a big fan of this. I've done a lot of stratified sampling in my time. So you basically identify the target population and then you stratify it into subgroups or subregions. So let's say you're interested in socioeconomic impacts of COVID, and therefore you're probably wise, if you're going to sample households within Fairfax, to break down the households into the size, so the number of people, the demographics of the people who live there, so age in particular, socioeconomic status, potentially race as well, gender. These are all factors which could have a really large impact on the actual desired results that you want to gain. So, how have people been affected by COVID? Maybe households where the main earner is able to do their job remotely over the internet have been less affected by COVID, whereas those jobs where maybe you have to go face to face to see people, or you need to go to a factory or somewhere like this, and that's been more affected by COVID because there might have been a change in the way the business has to operate to avoid transmission, for example. So these are the types of things that you need to consider when you think that might be a key issue in the targeted sample. Okay, so you might want to consider also the spatial size of different subgroups or subregions, and you can essentially target these areas based on any sampling design. Generally, I think that this is a much more representative approach if it's been designed well, and generally it's unbiased, but it is more complex to implement. But you'll see many statistical authorities around the world designing their population surveys or labour market surveys in this way, and they'll stratify if it's a labour market survey based on the industrial sector or the size of the company, and then if it's a household survey, then based on the characteristics I already mentioned. Okay, let's move on. So cluster sampling. Imagine you have the target population, and what you do is you divide it into subgroups. So maybe these are 1 kilometre tiles down here. And then what we're going to do is select an appropriate number of clusters. Maybe that's 10%. And then maybe within that, we're going to then go into each one of those cluster areas, and then we're going to pick random samples. So let's say we want to measure the temperature or take the soil pH. We might take 4 out of 25 squares, as we've done here. And then within each of those 4, we're going to pick another 5 sample points at random. So this, could help to decrease the cost overall rather than doing a very large sample. But you can get into issues if internally these tiles, aren't homogeneously quite similar. So this would be quite bad if you wanted to just put this grid over Fairfax City, because you could get one cluster group that was like the very centre of the city and had a higher density, or you could get one of those cluster groups at the edge of Fairfax City, where maybe you have suburban homes getting into a rural area, and therefore you've got far fewer houses or people, and that's not necessarily representative of the whole study area. So you need to be aware of this bias. Hybrid sampling. So you could combine various sampling designs. So you could use a stratified systematic non-aligned sampling approach. So you cut the region, as I've done here, into equally sized grids, and you place a sample point randomly within each grid. So it's systematic by having all regularly spaced grids, but then the samples are stratified based on the grid. So you've got 1 sample per grid square, and it's random within that area. So there's meant to be a better distribution throughout the region by doing this, but you need to make sure that you get the right sized grid squares. So this goes also back to the modifiable aerial unit problem, which we covered previously. Okay, so this draws to a close the 6th lecture on sampling. Watch out for the midterm exam that I'm going to be setting in due course. So I'll make you aware of this. I'll reach out to you via email just to explain that we'll be doing an exam this week. If you've got any further questions, don't hesitate to get in contact with me, and please make sure that you get all of the tests and also the discussion board content completed, please, so that then you're fully prepared for taking the exam that's going to be set in due course. Okay, fantastic. Thank you very much for tuning in, and I'll see you all soon. Goodbye.